that usually translates, I can't integrate it. Or, as I told you a minute ago, I don't want to integrate it. Questions? Travis?
So, you would always look to use something like this test whenever the denominator has some number added to?
Yes. Yes. But think about your question now. Travis asked exactly the right question. He said, you would think about using this test when the number has something added to it. And I said, yes. But I did not guarantee Travis that that would work every time. His words were, think about using it. And I said, yes. And if he'd asked me the next question, and it will work every time, I would have said no. Okay? I'm going to show you one. I'm going to show you one. Okay? All right? How about 2D on page 578? And that is the series you've already sniffed this one out, and I have just gotten it written, haven't you? First thing, let's go through the steps real quickly. The first thing is, step 0, is the limit of that 0? Yes or no?
Yeah.
It sure is. So that means we keep on going. Step 1 is it a geometric series? No. However, isn't there a however? Isn't there a however based on Travis's question? What did Travis ask me? He said if you have added or subtracted a constant, wouldn't you think about using the comparison test? So if I were to use 1 over 2 to the n, is that a geometric series?
Yeah, that is.
It is, because isn't that 1/2 to the n? Do you follow? Okay, so I'm going to do that. I'm going to say a sub n is equal to 1 over 2 to the n minus 1. Everybody agree? And now, so I don't give away my hand, I'm going to just call this, I'm just going to call this T sub n. T sub n is going to be equal to 1 over 2 to the n. But that's equal to 1/2 to the n. Is that right? But that is a geometric series with R, what? What's R? 1/2, sure it is. Sure it is. R is 1/2 with R equal to 1/2. Is that right? Does that converge or diverge?
Converges.
What?
Converges.
It converges? Is that right? Well, let's see. Look back at the geometric series test. It is the first term, right, divided by 1 minus R, huh? Isn't that it? Isn't that it? Am I right?
This is R is got to be less than 1 for it to converge.
That's what I wanted you to remember. R has to be less than 1. The absolute value of R, right? So this absolute value of R is less than 1, isn't it? So it converges. So the absolute value of R is less than 1, therefore it converges. Now, consider A sub n and T sub n. I just called it T sub n because I didn't want to use B sub n and C sub n. Because you're used to, if I use B sub n, that means A sub n is going to be larger. And if I use C sub n, that means A sub n is going to be smaller, right? But in the real world, you're not going to know that in advance, so you're not going to know which one to call it, right? And I didn't want to tip my hand by using one of those, so I just picked another letter of the alphabet. Follow? Okay? I need somebody to offer me an expert opinion. Are the numerators the same? Yes. Which one has the smallest denominator?
A sub n.
What?
A sub n.
A sub n does indeed. Therefore, doesn't that mean that A sub n is the largest? Is that not our up and down deal? Okay. Therefore, Dr. Thomas,
Ain't gonna work.
therefore, nothing. Does everybody agree? Do you follow? What I've said is I've said T sub n converges. And if A sub n had been less than T sub n, it would have converged, wouldn't it? Is that right? But unfortunately for us, A sub n is larger than T sub n. So we have proved precisely nothing. Do you agree? Now, out of the 9 of us, 3, 6, 7, 8, 9, out of the 9 of us, Dr. Thomas and Ms. Voss could integrate A sub n. And the other 7 of us ought to be able to. And if you'd let me play with it a little bit, I'd integrate it right now, but I'd have to check my answer to be sure, because I'm a little rusty on it, but there is a way to integrate 2 to the x, is there not? Is there not? So what I'm telling you is I could integrate it, but I choose not to. So we proved nothing. Now what? Nothing means, that does not mean that it diverges. It means that we can't tell whether it does or not. Do y'all remember in college football when they do a replay? They're now doing it in baseball. When they do the replay official wants to look at something. Doesn't the NFL have replays now too? And they look at the play that was on the field, and they can come up with 3 possibilities, right? Yes, you got the play right. No, you missed the play, therefore overturn the call. And what's the one in the middle?
We don't know for sure.
Inconclusive. Isn't that the word they use? Inconclusive. Aren't we at inconclusive? That's all I'm saying. So what do?
Go to the next test.
Go to the next test. And the next test works beautifully right there. And I'll show that to you. I'll show that to you on Wednesday. That does not mean I'm quitting for the day, though. That means I got 5 more minutes and I'm going to work a problem. So, use LCT on Wednesday. Okay? I do want to work one more. How about number 12 on page 580? Does that test converge or diverge? Does that series converge or diverge? We're guessing now, so it don't matter. Ed, does it converge or diverge?
It converges.
It converges. I agree. Beth, would you have said it converges? Let's pretend for a minute the 1's not there. Isn't 2 to the n divided by 4 to the n 1 over 2 to the n? Is that correct? And you can show that that converges, can't you? Agreed? Okay, so that's what I'm going to do. I'm going to call this, so a sub n is equal to 2 to the n, 2 to the n, let me make it look that way, 2 to the n over 3 plus 4 to the n. But I think t sub n, I'm going to let be equal to 2 to the n over 4 to the n, which I think is 2/4 to the n, which is equal to 1/2 to the n, which is a geometric series with r equal 1/2, is it not? Therefore, converges. You have got to tell me why it converges. If you don't, you haven't told me it converges. Okay? And also, would you say that A sub n is less than or equal to T sub n for every value? Which one of them has, do you agree the numerators are the same? Yes or no?
Yeah.
The numerators are the same. Which one of them has the smallest denominator?
T sub n.
T sub n, right? And doesn't that mean that if it has the smallest denominator, then the whole fraction is the largest? Do you see how you can mess that up if you don't think about it right? So think about it right, huh? Okay? All right. Therefore, A sub n, therefore the series A sub n converges by the comparison test. What do you think? Get the idea? So the comparison test is a beauty. It is a wonderful test when you are adding or subtracting numbers in either the numerator or the denominator, not just the denominator, when you're adding or subtracting numbers in either place. But just as the one before this, you run into problems when things don't work out the way they should. I'll fix that on Wednesday. See you Wednesday.